When HJC committed to creating an all-new premium helmet, the innovative RPS-10, the company also made a huge commitment to expanding its facilities and gearing up for the RPS-10 production. For years, the HJC plant had already been regarded as one of the foremost helmet manufacturing sites anywhere, in keeping with the company's standing as the #1 manufacturer in the world. But the efforts required to design and build the top-of-the-line RPS-10 required a whole new level of expansion. The very first forms of the RPS-10 began as design sketches that morphed into CAD designs and interim models built via rapid 3D prototyping. A helmet designer can have many good ideas in mind while sketching up new shapes, but there's really only one way to know for certain if specific elements will achieve the desired results. Build it, test it, then do it again and again. And so HJC engineers embarked on a development process that stretched on for 3 years in the creation of the final product. 3 different development teams worked on various designs during this time, and more than 20 different prototypes were created and tested. Each prototype was thoroughly evaluated, and with each new step, the design was tweaked and reshaped for reduced aerodynamic drag, maximum stability, minimum lift, minimum vibration and noise, and more. Based on these testing results, the existing prototype would be revised, and a next generation prototype would then be designed and constructed, and the testing process resumed once again. In time, the final form was created. As you inspect an RPS-10 carefully, you'll note subtle compound curves and complex structures shaped into the upper and frontal areas of the shell. The complexity of the shell shape becomes readily apparent, and for good reason. These shapes play a major role in establishing the correct aerodynamic properties. And that didn't happen by accident. It happened through an inordinate amount of R&D with plenty of the most modern equipment available, plus tons of plain old hard work. In order to conduct such tests, HJC built a new oversized wind tunnel capable of admitting a complete motorcycle and a rider, a substantial commitment in capital outlay and space. Motorcyclists live in a world filled with wind, a wind stream that does not stay constant. Whether the day calls for gentle meandering and sightseeing down a shady country road, or handlebar to handlebar racing at triple-digit speeds, the rider encounters ever-changing wind conditions with the rider's head and helmet constantly taking on different positions. As a result, it makes perfect sense to test a helmet's form for aerodynamic efficiency and stability in a full-size wind tunnel while it is strapped onto a test engineer sitting aboard a motorcycle. And this is what motivated HJC to build such a facility and conduct extensive testing. With the new RPS-10, dynamic tests with a helmeted test engineer were performed at wind speeds up to 130 miles per hour. Why such high speeds? Certainly because racers regularly attain such velocities and more. But consider this. Should a rider heading down the freeway at 70 miles per hour encounter strong headwinds of 30 miles per hour or more, such an everyday occurrence easily surpasses the 100 mile per hour mark, which is to say a helmet's superior aerodynamic performance gained through wind tunnel testing at high wind speeds can benefit all riders. And HJC's Design Center also contains one of the most comprehensive testing labs in the industry. Not only does the lab allow for dynamic testing for European and SNEL standards, but it also contains special tests devised by HJC's engineers to ensure quality and durability. With the design finalized, a completely new method of helmet manufacture and production facility had to be devised to produce the RPS-10, which is the lightest SNEL 2010 approved helmet on the market. The plant was expanded, and the HJC engineers established an all-new manufacturing process, one that incorporates a pre-molding technique to carefully locate and shape the layers of the lightweight and strong premium integrated matrix material with exacting precision. The degree of precision was so demanding that it could not be automated. Only the human eye and hand can make the necessary judgments to meet such a rigorous standard. In the end, it took more than a year to develop and perfect this single manufacturing technique, and of the hundreds of people employed at the HJC manufacturing plant, only 6 are qualified to perform this pre-molding process that is so integral in the creation of the RPS-10 shells. The inclusion of all these new facilities require a substantial commitment in capital outlay and space. But for HJC, the benefits attained with superior designs and newfound efficiency certainly made the cost of building such additions more than worthwhile, and the new RPS 10 stands as indisputable proof.